Okay, let's go ahead and take a look at a particular type of sequence that is going to be very important for us to look at, and that's the monotonic sequence. Now again, what we're trying to do is to take a look, is it converging or is it diverging? Okay, a sequence is monotonic if a sub n plus 1 is greater than or equal to a sub n, or a sub n plus 1 is always going to be less than or equal to a sub n for all positive values of n. Now notice, the only thing that's different between these two is the direction of the inequality sign. But the direction of the inequality sign is going to be very important for us to really take a good close look at, because in one situation you're talking about a monotonic increasing sequence, and in the other one you're taking a look at a monotonic decreasing sequence. So let's just take a look at this one first. Notice that this one's coming here. It's saying that for every a sub n plus 1, so in other words, if here's the first a sub 1 value, then the a sub 2 value always has to be bigger than the one before. It always has to be bigger than the one before. So that means then that what we're talking about in this particular situation is a monotonic increasing sequence. Now in the same regard, if we take a sub n plus 1 is always less than a sub n, so if you have a sub 1 and a sub 2 has to be less than that, a sub 3 has to be less than a sub 2. So what that means then is that you're coming out with a monotonic decreasing sequence. So it's going to be very important for us to go ahead and realize whether or not it is greater than or equal to or less than or equal to, because that's going to tell us whether or not it's a monotonic increasing or decreasing sequence. Now the important result that's going to come from this, it says a monotonic sequence of real numbers is convergent. So again, notice we're talking about converging or diverging. It is convergent if and only if it is bounded. So if it is bounded, then that means that the monotonic sequence is going to converge. Now it has to be bounded in order for that to happen. Now how do we go about determining whether or not a monotonic increasing how to determine if a sequence is monotonic increasing and bounded? Okay, let's go ahead and take a look at this. It says, for example, we need to show that a sub n plus 1 is greater than or equal to a sub n for all n, or you can show that the associated f of x has f prime of x greater than 0 for all x, which means that it is increasing, and also that f double prime of x is less than 0 for all x, which means that it is concave down. So if it is always increasing but concave down, then that means that it is increasing, it's monotonic increasing, and it is also going to be bounded. Okay, so now of course this is only for the monotonic increasing situation. You can use the same similar type of argument for the monotonic decreasing as well. Now let's go ahead and take a look at an example here. Like say for example we have a sub n is equal to 3 to the n divided by 1 plus 3 to the n, and we want to determine whether or not this particular sequence is monotonic or not. And is it? So let's just go ahead and say that a sub n plus 1 is greater than or equal to a sub n for all n. Is that going to be true? Now if we just go ahead and do this substitution here, because this is our initial statement, we have 3 to the n plus 1 divided by 1 plus 3 to the n plus 1 greater than or equal to 3 to the n over 1 plus 3 to the n. Now, what we need to do is we need to go ahead and try to simplify this so that we can actually go ahead and start determining whether or not it is true. And one thing that we can do, of course, is we can go ahead and change this here to 3 times by 3 to the n and do the same thing to the denominator there. Now, being that I know that 3 to the n is going to be a positive value, I can go ahead and multiply both sides by 1 over 3 to the n and 1 over 3 to the n without changing the direction of the inequality sign. And what will happen, of course, is that this will cancel with that will cancel with that. And what I'm left with is 3 divided by 1 plus 3 times by 3 to the n. Is that greater than or equal to 1 over 1 plus 3 to the n? Now, again, the idea here is that we want to try to get as many of the parts similar, because the more that's similar, then it's going to be easier for us to be able to compare whether or not the inequality is true. So what I'm doing then is I'm multiplying both sides by 1/3, because I want to try to get this here to a 1 so that the numerators are the same. So if I do that, then what I come out with is 1 divided by 1 plus yes, 1 plus 3 times by 3 to the n. And notice that I just need to distribute the 3 here to the denominator to come up with 3 plus 3 times it by 3 to the n. Now notice what I come out with then is 1 over 1 plus 3 to the n plus 1. Is that going to be greater than or equal to 1 over 3 plus 3 to the n plus 1? And what we should know is that since the numerators are not going to are the same, we just need to consider what's happening in the denominator. The denominator on this side and the denominator on this side, if we compare them, this is always going to be a larger denominator than this one. Being that the denominator is larger, then the fraction as a whole is smaller, which means then that this inequality that we have here is true, and therefore it is monotonic increasing. Now, if we wanted to go ahead and find out what it is bounded by, we can go ahead and say that the limit as n approaches infinity of 3 to the n over 1 plus 3 to the n is the same thing as dividing all the parts by 3 to the n over 3 to the n. So that's 1 divided by 1 over 3 to the n plus 1. Of course, as n approaches infinity, this 1 over 3 to the n approaches 0, and I come out with 1. So it is monotonic increasing, and it is also bounded, therefore it's convergent. Okay, and so there you go. That's what we have for that example. So what we're doing again is we're taking a look at a very particular type of sequence. It is called a monotonic sequence. We have monotonic increasing or monotonic decreasing, and the primary result is here. A monotonic sequence of real numbers is convergent if and only if it is bounded. And so what we want to do then is we want to determine how we can do that. We can show that either a sub n plus 1 is greater than a sub n for all n for an increasing monotonic. And then in order to show that it's bounded, we can also go ahead and show this as well. And then we have an example here to go ahead and show that in fact this particular sequence is going to converge. Okay, so we'll go ahead and take a look at more of these in class the next time that we meet. See you later. Bye-bye.